All right, so we're going to start off by doing a review of separable differentiable equations, and then part 2 is actually the second part that I haven't been able to teach you guys. So, separable functions. Differentiable functions are where the derivative is equal to a function in terms of x times a function in terms of y, or it could be f of x divided by g of y, or it could be g of y divided by f of x. So if you look here, these are separable because x times y. This is separable because x divided by y. And this is separable because it's x times y. These are not separable because this is a sum. This is not separable because this is subtract. And the rule about separable, you can only move terms by multiplying or dividing. So, moving on, let's do some examples. First here, I wanted to do this example because it's a different notation. I want to make sure that you do understand this notation also. So, it would be xy plus dy dx equals 20x. So, in this case, this one is separable. We're going to move the term xy to the other side, and right now it looks like it wouldn't be separable, but you notice there's a common factor. The common factor is x, so I can factor out x, and I would have function of x multiplied by a function of y. Next step would be, and I'm going to come up here, separate. So I'm going to take this function, and then the dx I'm going to take to the other side. What that means is now I can take the integral of both sides. The right function is obviously easy because that's x squared over 2, and you know that, plus c. The other side, though, is a little bit harder because we have, I'm going to end up running out of space here. We have essentially a u substitution, but I'm going to do this without. The bottom would be u. The dn is -1. So really what I have is the ln of 20 minus y divided by -1, so I'm going to put the negative in front. What that means for us is now I am going to take this function, divide by -1, I'm then going to take both sides to the e. This is that long process we did in class together, which cancels the ln. I am left with the absolute value of 20 minus y equals e to the -x squared over 2 minus c. Because of that minus c there, I am going to change that into e to the a times e to the b. In the same exact step, I'm going to eliminate the absolute value by putting the plus or minus. Remember I said I'm going to do e to the a times e to the b. Then I will take all the parts that are a constant and do a substitution where I'm going to let that be the a constant. And then all I have to do is subtract 20 and then multiply by -1. So negative y is equal to a e to the -x squared over 2 minus 20. And then y is equal to negative a e to the -x squared over 2 plus 20. Oh, there we go. So that process of using the a, so here I let a equal plus or minus e to the -c. And I can do that because plus or minus e to the -c is a constant. Moving on, another example for you would be this one here. So I'm going to separate. I'm going to take the integral of both sides. And on this side I get y cubed over 3. On the other side I get x squared over 2 plus 2x plus c. Y cubed is equal to x squared over 2 plus 2x plus c. And then I'm actually going to multiply the whole thing by 3. And last step, I'm taking a cube root, so I don't need a plus or minus. And you can either take the cube root or you can raise the whole thing to the 1/3 power, but both would be the same. All right. And then lastly, I have a free response question. So this one, I'll be honest, I'm not sure where I took it from. And if you haven't seen it, then that's actually pretty good. So we can go through the whole thing together. On the set of axes provided, sketch a slope field for the given differential equation at 12 points. So I'm going to do the easy ones. If x equals 0, then the slope is 0. I also know that if y equals 1, the slope is 0. So those are my easy values. And then here, the slope would be, the x value is -1, so that'd be 1 times -1, which is -1. This would be +1 times -1, which would be here. This up here would be -1 squared is still 1, and then it's 2 minus 1, so it'd be +1. This is still 2 minus 1, so that's +1. That doesn't look +1-ish. There we go. And then this y value is 1, 2, 3. 3 minus 2 is 4, and 4 would be a little bit steeper. And then here, well, not 4, just kidding. 2, I believe, is the number I'm looking for. So 1, 2, 3 minus 1 is 2. 3 minus 1 is 2. The x squared for all of those was 1. So there's part A. Part B asks you to, given the slope field drawn, describe all points for which the slopes are positive. So you will not list a bunch of points. You will find where dy dx is equal to x squared times xy minus 1, and where that is greater than 0. Now, to do a little bit of an analysis, you'll find that this term is always positive. So we don't really care about that when I'm looking for the sign of dy dx. In this case here, y minus 1, you want that to be bigger than 0 so that the two terms multiplied would give me a dy dx that ends up being positive. So we can actually just solve this because it's an easy one to solve. Y is greater than 1. But on top of y being greater than 1, you also need an and statement that says x cannot equal 0, because if x equals 0, then you would actually get the slope to be 0. So I'm going to put that underneath so I have a little bit of space. Otherwise, usually you'll see in my notes I do kind of like a sign chart where this value would be equal to 1. The slope would be 0. If I put in a negative y value, that would cause y minus 1 to be negative. And if I put in a positive y value bigger than 1, it would cause it to be positive. So that also would answer when the slope is negative. Part C, find the particular solution to the given differential equation with the initial condition. So I'm going to do a separable differential equation. I'm actually going to move this to a different page. So there's my differential equation, and I'm going to solve it with an initial value. So it's separable, meaning the function of x is multiplied by the function of y. So first thing I'm going to do, I'm going to move the terms around so that the x's and y's are separated. I'm going to take the integral of both sides. This problem should look somewhat familiar. We've done something similar to it. So now we're going to take the antiderivative of both sides. Sorry if that sounded chopped up. I actually just walked away for a minute. So antiderivative of this would be the ln of u divided by the derivative of the inside, which is +1, see, equals s cubed over 3, and then your plus c. Wow. So I'm going to take both sides to the e power, and I'm actually going to erase this divided by 1. I wanted to put that there so you don't ever forget to divide by the derivative of the inside. I'm doing these without substitution because the dn is a constant number 1. So take both sides to the e power, cancel, and I get the absolute value of y minus 1 is equal to e to the x cubed over 3 plus c. And then from there, remember, we do eliminate the absolute value by using a plus or minus. We separate these terms, and we write them as common base of e. Then from there, we are going to highlight the plus or minus and the e to the c and let that be a. And so now we get that y minus 1 is equal to a e to the x cubed over 3. And therefore, y is equal to a e x cubed over 3 plus 1. And then the initial condition goes in. The y value is 3. The x value is 0. So 3 is equal to e to the 0 is 1. So So I actually get a plus 1. Therefore, a is equal to 2, and the actual function would then be 2e to the x cubed over 3 plus 1. And there we go. That should be the last part of this video. Hopefully that was helpful, especially for those that did not do well in the 6.1 quiz. You now should really be able to see how to do the positive and negatives on the slope field.